Hello again, Year 8, and welcome to Lesson 8 of Acids and Alkalis. What you'll need with you today is a pen, ideally blue or black, for you to use to fill in your booklet, and a pen in a different colour for you to make corrections and mark your work. So pause the video now if you need to collect anything. So what are we going to learn today? So we have 3 objectives. You're going to understand that soil can be acidic, alkaline or neutral. You're going to explain how the pH of the soil affects what will grow, and investigate soil samples to determine where to plant different crops. Before we start, you need to get your spider diagrams out, add a branch, the heading Lesson 7 and circle it, and then add 3 bits of information that you remember from last lesson. As always, if you can't remember 3, you can look some up, but you add those in a different colour. Just pause the video while you do that now. Okay, in your booklet you have this page about soil and pH. So soil contains different chemicals depending on where it has come from. Now this means that you can identify where soil comes from based on its pH. So soil was found on the carpet at the scene of a crime, and collected from each of the suspect's shoes. So we can see which suspect has been to the crime scene to check that by checking the soil matches the pH of the soil at the crime scene. So to see how acidic or alkaline the soil is, we can use a universal indicator. So I want you to quickly pause the video and fill in these 3 gaps here. So if the soil is acidic, the universal indicator will turn red, orange or yellow, and if the soil is alkaline, the universal indicator will turn blue or purple. If the solution is neither acid or alkaline, it is neutral and the universal indicator will remain green. So we're going to do an experiment where we're going to use soil, got a sample from the crime scene, and then a sample from each of 4 suspects. We're going to add water to the soil to extract any acid or alkali, filter away the soil, and then add universal indicator to find out the pH. As we do that, you are going to add the colours into your table and then work out the pH from this and say if it's a strong or weak acid or alkali or neutral. So here's the samples, got the crime scene, and then the 4 suspects. So we're going to extract any acid or alkali from the crime scene. So we add our distilled water. Give it a really good stir, make sure it's all mixing. We then set up our filter paper. And we filter the solution. And we always take care not to let the top of the liquid in the filter go above the filter paper, because then some soil might pass through. So the filter paper is going to stop the soil coming through into the bottom of the conical flask. So as you can see, we're getting a colourless liquid coming out the bottom of the filter. We're going to use liquid universal indicator, but you could use the universal indicator paper strips instead, which are a bit less hazardous. Okay, we're nearly finished filtering. So we're going to get ready to remove the filter and add the universal indicator. We're going to add plenty of universal indicators so we get a nice strong colour to make it easy to identify. So here we've got the extracts from the 4 suspects as well. We're going to add universal indicator to each one. So don't write down the colours just yet, wait until they've all been swirled and you can see the colours fully. So here are the results for the crime scene, and then the matching one has been put next to it, and then you've got the rest of the results there. So pause the video if you need some time to finish filling in the table. So as we go through, if you do make any corrections, remember you do it in a different coloured pen. Okay, so the crime scene turned the universal indicator red, giving it a pH of 1, making it a strong acid. Sample 1 went blue-green, making it a pH of 10 and a weak alkali. Suspect 2 sample went orange, giving it a pH of 3, making it also a strong acid. Sample 3 went red, giving it a pH of 1, making it a strong acid. And sample 4 went green, giving it a pH of 7, making it neutral. Okay, so now you need to draw your conclusion. So in your conclusion, you need to write which suspect had been to the crime scene and how you know this, and how you know that the other suspects have not also been to the crime scene. So pause the video while you write your conclusion. Okay, I'm going to show you my conclusion now. As always, you don't need to match it word for word. You just need the same information. And if you do make any corrections, remember it's in a different coloured pen. So this is my conclusion. So the soil sample from the crime scene turned the pH indicator red. This means it has a pH of 1 and is a strong acid. Now remember, anytime you write pH, it needs to be a little p and a capital H. The soil sample with the matching pH is sample 3. It also turned red in universal indicator and is a strong acid with a pH of 1. Therefore, suspect 3 must have been present at the crime scene. Now, sample 2 was also a strong acid, but with a pH of 3, so it did not match the crime scene. Sample 1 has a pH of 10 and is an alkali, so does not match the crime scene. Sample 4 is neutral with a pH of 7, and none of these suspects could have been present at the crime scene. Okay, moving on. So we have Farmer John, and he needs your help. So what he said is, please help me. I have 4 fields and I want to grow tomatoes, wheat, lettuce and corn, but I don't know which field to use for each. Please help me decide where I should plant my crops to get the best yield. So you've got some fact sheets in your booklet. I'm going to go through them with you now. So you've got a fact sheet about tomatoes. So they need a lot of water and sunshine. They need a low acidic soil to grow in. They produce a large number of fruits. The plant will die off during the winter. And the plant leaves the soil strongly acidic after fruit has been picked. Wheat can survive with the water provided by rain. No extra watering is needed. Prefers a strongly acidic soil when planted. Plants will produce a good amount of wheat, and the plant will leave behind a weak alkaline soil once harvested. Lettuce. The plant likes a lot of water as it grows. The plant does not grow very high. It leaves behind a strong alkaline soil when harvested. And it should be harvested just before they turn completely green, and will need a weak alkaline soil when planted. And lastly, corn. Corn or sweet corn is a healthy part of any meal. Corn is nice with melted butter on top. Corn requires a strong alkaline soil to grow. It grows very tall and leaves behind a weak acidic soil once harvested. So how are we going to help Farmer John? So you have been given 4 different soil samples from his 4 fields, A, B, C and D. A solution of dissolved minerals from each of the 4 different samples has already been prepared. Use an appropriate indicator to test the solution and record your results below. So have a think, what indicator would you use? Some want a strong acid, some want a weak, some want a strong alkali, some want a weak. So which one would you want to use? Hopefully you would say universal indicator. So you've got your table, you've got your 4 samples. I'm going to show you the video. You're going to write in what colour the indicator went, therefore what pH value it means, and if it's acid or alkali, and if it's strong or weak. Okay, so we have our 4 soil samples. We're going to use universal indicator because we need to know more than just is it an acid or an alkali. Litmus wouldn't be able to tell us that. So we're going to add a few drops to each, and then we're going to need to shake them to get it to go through the whole solution. And here you can see the results. I'm going to bring each one close up to the camera so you can see it more clearly. So there's A. Nice purple shine to it there. B. It's an orange yellow almost. C is red. And D is a dark green. So make sure you record those results. Okay, so we'll go through the results now. Remember, any changes to do that in a different colour. So field A. That went purple, giving it a pH of 14, making it alkaline, and a strong alkali at that. B went a yellow-orange, pH of 4, making it an acid, weak acid. C went red, giving it a pH of 1, making it a strong acid. D went a dark green, giving it a pH of 8, making it an alkali. So you've got this table next. You need to tell Farmer John which field to plant each crop. So pause the video while you do this, using the experiment results. Okay, so let's go through this. Lettuce was in field D. We're going backwards through the fields here. So D would be where you put your lettuce. C, you'd put your wheat. B, your tomatoes. And A, your corn. So you should have used the information in the fact sheet to help you do this. So here's Farmer John again. It says, thank you, that is so helpful. Now I know where to plant my crops. I have one more question. Should I always keep these crops in these fields, or will I need to rotate them? Look back over your fact sheets and have a think. What would you say to Farmer John? How would you answer his question? Pause the video while you do this. Okay, hopefully you said that he would need to rotate them based on how they leave the soil behind. Some will leave it slightly alkali, some will leave it strong alkali, weak acid, strong acid. It does depend on the plant. So we've got today's fun fact zone, a bit late in the lesson today, but we didn't forget it. So up until around 10,000 years ago, all humans were hunter-gatherers. Around 9,500 BC, it's a rough time, the practice of agriculture, farming, began to spread across human civilizations. Now, these early farmers grew wheat, barley, peas and lentils, and we have evidence from 9,500 BC of this from around modern-day Egypt and the West Mediterranean. Here's some old Egyptian paintings you can see of them farming, and you can even see the wheat husks in here. Now, these early farms were small and provided only enough for the tribe to eat or trade for other resources with nearby tribes. And no one knows how humans discovered farming or how it spread across the entire world. Now, next lesson we'll have part 2 of this fact, which will look at how acid and alkali is impacted on farming. So before you finish today, you need to test your knowledge. There is a self-marking quiz into this lesson. Make sure you do this before you finish. And remember to add any new keywords to the table at the front of your booklet. Thank you, Year 8. I'll see you again next lesson.